In this video, we will be learning about how to calculate the correlation between two variables. So far, we have studied how to find the correlation between two variables qualitatively, meaning we would look at the scatter plot and we would try to guess what type of correlation it is, if it's strong, moderate, or weak, just based on where the points are. Today, we're going to be learning how to actually calculate that. So the calculation we're going to be learning about is to find the correlation coefficient. That's the number that tells us how strong the correlation is between the two variables. The variable or the letter that represents the correlation coefficient is the letter R, lowercase r, that represents the correlation coefficient. And the numbers that we're going to be calculating are always going to be in the interval from -1 to 1. So you will never have a correlation coefficient that's bigger than 1 or that's less than -1. It's always numbers that vary between those two. So if we look at this table below, it gives us an idea of how to determine which number is assigned to which strength of correlation. So for example, here we have our correlation coefficients can be positive or negative. The sign only tells us the direction of the slope, which way the points are kind of leaning to. So if we get a correlation that's very close to 0, either positive or negative, it means that there is a 0 correlation between the two variables. There's no correlation at all. If we calculate a number that's close to 0.5 or -0.5, it would indicate a weak correlation. 0.75 to -0.75 is moderate. 0.87 to close to -0.87 indicates a strong correlation, and if it's equal to -1, oh sorry, that should say positive. Let's fix that. So this should be equal to +1 or equal to -1, then we have a perfect correlation between the two variables. So basically, the closer we are to 1, the stronger the correlation. So let's write that down. Closer to 1 or -1, the stronger the correlation. Now these values that you're calculating, these numbers that you're going to be getting, are approximate values. That means they're not exact values. The reason is there's a little bit of maybe estimating that you're doing when you're calculating, and you'll see when I show you how to calculate it. So they're not exact values, they're approximate values. And since they're approximate, we don't represent it with an equal sign, we represent it with this approximate sign, which is like a squiggly equal sign. So whenever you see this symbol here, it means it's approximately equal to. So to calculate the correlation coefficient, we use a graphical estimation. So we are going to be estimating from a graph. And because it's an estimation, that's why we get an approximate value. It's not an exact value. So the steps to do our graphical estimation are listed here. And I'm going to illustrate using an example. So step 1, we have to represent our two variable distribution on a scatter plot. Now, we already know how to do scatter plots. We saw this last couple classes. So the first thing we do is draw our scatter plot. Step number 2 is we draw a line that represents most of the points, the line of best fit. Basically, the line of best fit are going to be, you're going to draw a line that's going to try to touch as many points as possible. So it's a kind of an approximation, it's a guess. So I'll show you with our example here. So here we have a scatter plot that's already been drawn. So ignore the rectangle for now. We'll talk about that in a minute. So we have all our points for our scatter plot. And then we draw this line of best fit. We kind of guess with a ruler where this line should be so that it's close to as many points as possible. Then step 3. We construct the smallest rectangle possible, framing all the points. So that's what we did here. We have our rectangle that goes around as many points as possible. Well, actually, it goes around all the significant points. And what that means is if we have an outlier or a point that doesn't fit the pattern of the other points, we wouldn't include it. So an outlier, let me just prepare my pen here. Okay, an outlier would be something like this. Say we had a point that's way up here or way over here. It's not fitting in with the other points. It's not fitting the pattern, so we call that an outlier. And in statistics, when we have outliers, we ignore them because they're not fitting with the same trends that this data is showing. So once we've found our rectangle that we have here around all the significant points, these ones are significant because they're following the trend, then we can calculate the correlation coefficient R using this formula. So our R is equal to, well, plus or minus. The plus or minus here, you decided based on the slope of your line. So plus or minus 1 minus the length of the short side of the rectangle divided by the length of the long side. So we need a ruler to measure the lengths of these two sides of our rectangle. So let's try this calculation. So my R is approximately equal to, now I need to decide on the sign. Well, if I look at the line here, the slope is positive, the x is increasing, and the y is also increasing. So my slope is positive, I'm going to make it plus. And then I'm doing 1 minus the short side, which is 12, divided by the long side, which is 41. And then you can calculate that on your calculator. You're going to get positive 0.71. So that tells us of the strength of the correlation. So if we go back and look on the first page, 0.71 is probably the closest to a moderate correlation. And it's positive. So we have a moderate positive correlation. Okay, don't stop the video now. Now I'm going to show you the secret question that I'd like you to answer for next class. So this is the question from the video. I'd like you to write this down and solve it, please, and bring it to class, and I'll be checking it next time we meet. So list the following correlation coefficients from weakest to strongest. Put them in order from weakest first, which one is the weakest correlation, to the strongest.